This question is find the leaf of a binary tree. So you are given the root of a binary tree. So collect all of the leaf node, and then remove all of the leaf node, and then repeat until the tree is empty. So this question is pretty, challenge for sure. And if you don't know how to do it, you need to use a recursion. And I have two solutions for this one. The first solution is going to use in the idea of like your idea of like you are pointing at the left of the child, and then you keep pointing at your left, and then when you are a child, right, you add into the list, and also you want to point at your right, and then do the same thing, and then until you reach the node, which is like the child of the leaf, and then you are collecting all of the leaf, right? Then you are redirect the leaf to the node, so you are just basically point at this, right? So you're changing your pointer, right? So this will be a first solution, like you are changing your leaf, your children to the leaf, and then you have to do it recursively, right? And then until the tree node, the root is empty, right? And then this is going to be a first solution, and the second solution is going to use the height. So again, this is a for the leaf, the height is 1, right? And then for this one, this is what the height of 2, right? And this is going to be what? So if there's height of 2 for the left and height of 1 on the right, this is going to be what? 3, right? Because you are taking the maximum of the children plus 1, right? So this is going to be a second solution. Let's talk about the first solution. First solution is going to be this. So list. So I need the return type list of integer, right? Result equal to new array list. And then I'm going to just pass in the what? Sorry, I'm going to return result. And then while the root is not empty, so while the root is not null, sorry. And then I need to create a list of integer, right? I'm going to call path new array list. And then I'm basically like keep updating my tree node to what? Keep updating my tree into the new construct of the tree. So I'm passing the root and passing the path, and then later on I will just say result.add. This will be what? New array list path, right? So now I need what? I need to update my tree node root, right? So this has to be tree node, and then I'm gonna call DFS, and this will be tree node. I'm gonna create a node, and then I'm passing the list of integer path, right? Alright, so the base case is gonna be if root is actually equal to the node, you return node. Alright, and then the next one is gonna be what? If your left and right are no, which is the leaf, you add the current value into the what? Into the path, right? And then you want to return no. So when you traverse your left and right, you are adding the value when you hit a leaf, and then you are actually change the current tree node to the node. So which means it's going to be at least node.left is equal to DFS. You point at your left and then path, right? You keep searching on your left until what? Until your node.left is what? Until your tree node is going to be the leaf, and then you redirect, right? And then exactly for the node.right, DFS node.right path, and then basically you update the node, right? Which is what? The root. So you have to think about the direction of the node, because when you hit the node for the leaf, right, you are adding the value into the path, and then you changing the current value to the node. Then you recursively back to the root, and then you return the node. So this is the idea, right? And submit. Yeah. So this is how it is, right? And it is a little bit difficult, right? So you keep updating your what, the root, until the root is not equal to null, right? So at some point like you pass in the one, I mean the last three node, right? One into the DFS, so null equal to this, and the first, I mean the base case are not, I mean the base case is not valid. So you go on this one, and then definitely these three node that left and these three node that right are null, right? You add the value into the path, and then you return a null, right? Then once you return a null, right, and then you go on the list, I mean you go back, you break out the DFS, because you are returning a null, right? And then in this one, like like you add a value into the path, then you're updating your root to the null, right? Because you're actually changing the value, right? Root is actually equal to null. And this is pretty much the idea. All right, it is a little bit difficult for sure. Okay, so the time and space are pretty straightforward. The time, you have to traverse every single element. So this is going to be all of n, right? And the space is going to be all of n. You have to add every single element into the what? Into a list of this integer, right? So all of n for the space, all of n for the time. And yeah, so the second solution is going to be using the height. So again, I'm going to pass in a list of, I'm creating result equal to new array list, and I'm adding the root, and what else? Actually, I can actually like initial my result to here. And I will just turn result, so I don't have to pass in the list of lists inside the DFS. So in this one, since I'm actually updating, I mean I'm finding my height, right? So this has to be int, even though I'm not actually assigning, right? So DFS tree null. No, so if the null is actually equal to null, right? Which is going to be what? 0, right? Alright, so if the null is actually equal to null, which is going to be like this. So you're still going to traverse on the left, traverse on your right, right? And then you will hit some point, it's actually equal to null, so you will return 0. And then the next one is going to be what? You want to find the height, right? So height is going to be equal to what? Max.max, and then DFS, and then you're going to traverse down your left, and traverse down your right, and then you want to plus your current level, which is plus 180m. Alright, so this is what? This is your current height. And on the current height, so imagine you're pushing your root into the DFS function, right? Now you want to find out the maximum for the height, so you are traversing on your left, traversing on your right, and the left one you are keep traversing on your left, because what? Because node.left is not null, right? So you keep traversing on your left until what? Until you hit the leaf. Until you hit the leaf of children, right? Then you are back to the 0. So now at this point, your node.left is actually 0, and then your node.right is actually 0 as well. So you want to plus 1 for your current level. So you plus 1 for your current level, because your children are 0. So you plus 1 at your current level, right? And then you have to know, do I have the value inside my list of integer? It can be based on what? Based on the size, right? So just look at this. For the output, the size is actually equal to 3, right? This is because you have what? 1, 2, 3. Size of, 3 different heights of the level, right? So using the idea to do that, just using the idea for the size, you can get a height, right? So if the result of size is what is less than height, I have to initial a new array list into the result. So I will get a new height and I'll push into it, right? So result I add new array list. And then once I know my new height, right? I want to what? I want to insert accordingly to my current level. So if I'm at this position, right? It's gonna be what? It's gonna be okay. So in the beginning, it's definitely empty, and I know my list height is 1, right? So I will create a array list, right? Now the size is actually equal to 1, right? So I can do the math. Say result.get. So how do you get the height? So this should be the index 0, right? So height is 1. So it's going to be height minus the size, right? I get the current element, which is going to be a new array list, and I will say dot add. So what do I need to add? The current value, no, right? So this will be the entire solution. So I'm gonna get my height minus 1, right? Dot add, no dot val. Then I want to return the height because I'm actually updating my height, right? And this will be a solution. So let me run it and submit. Yeah. So once again, when you're doing a recursive, solution, you have to think about like how you're supposed to reach the idea. So you want to find out your current height, and you want to compare your size, and then if the size is actually less than height, which means you want to add a new array list. And when you add a new array list, then you can just get the current index array list and add a value into the list of integer, which is a return type, right? And then you want to return a height because what, you want to keep traversing until the end, right? So this is pretty much a solution. So time and space are still the same. Space is going to be all of n. Time is going to be traverse every single element, all of n as well. So this is the solution. So it does a little bit, challenge for sure, but if you just do more practice, you can get it. All right, see you. Bye.